In this video, I'd like to just review the difference of squares, which is one of our special cases when we're factoring. The first thing we need to be able to do is recognize a perfect square binomial. So the first thing is, I guess, that a difference of squares is always a binomial. So number one, it's got to be a binomial. If we have a binomial, we want to check further to see if it is in fact a difference of squares binomial. The second thing, is there a minus sign? Okay, hence the name difference of squares. Difference means subtract, right? So we're subtracting two perfect square binomials. Subtracting two perfect square monomials, I should say. So number three, are they perfect squares? So we have to understand what a perfect square is, and I know in prior grades you would have learned that, of course, our perfect squares are, what are the perfect squares? So let's just review them really quickly. Okay, our perfect squares are 1. 1's a perfect square because, of course, 1 times 1 gives us 1. 4, 9, 16, 25, 36, 49. Where are we here? 64, 81, 100, 121, 144, 169, and so on. Okay, those are all perfect squares number-wise. When we look at a variable, a perfect square variable would be one such as x squared. Okay, x squared is a perfect square because, of course, I can multiply x by x to get x squared. Likewise, with the numbers, right, 9 is a perfect square because 9 comes from a 3 by 3 square. Okay, and 3 squared is, of course, 9. So whenever our root is the same, or is an equal number, a whole number, such as 3 or 4, etc., we multiply those together to get 9 or 16, etc., the 9, 16, etc. makes a perfect square. So we need to recognize those three things. Before we do that, let's look at some of the expansions, and we'll just get a little further background. So if I take x minus y and x plus y and expand those two factors, I expand those out, I get x times x, which would be x squared, and x times y, x times positive y, which gives me xy, negative y times x, which would be a minus x times y, and negative y times positive y would be a minus y squared, right? That last two, we multiply the last two there, we get negative y times x is our negative xy, negative y times y gives us our negative x squared. Now what happens here when we expand those is our two middle terms, positive xy and negative y, xy, cancel each other, right? We end up with a sum there of 0, okay, if we add those up. So our final simplified product is x squared minus y squared. So if I were to go in reverse and not expand, but if I gave you this, x squared minus y squared, and said factor that, if I said factor that binomial, you would have to recognize that there were two middle terms that canceled. And so when you factor that, you recognize it's a binomial. The two perfect square monomials are separated by minus signs, and the pattern is an x minus y times an x plus y. We take the square root of those perfect squares and we write them in that pattern. So let's just go out of here for 1 second. Let's expand a couple more just to sort of hammer that home. Okay, if we expand the three following factors, sets of factors, if I take and expand x times x, we get an x squared. x times positive 3 is a plus 3x. Negative 3 times x is a minus 3x. And negative 3 times 3 is a minus 9. So again, if I recognize then those two middle terms, those will cancel. The sum of negative 3 and positive 3x, negative 3x and positive 3x is 0. So our final product here is x squared minus 9. So how would I then find the factors of those? Well, I have to recognize that the pattern is an x minus 3, x plus 3. It's a binomial. Okay, looking down here, this is a binomial. If I was told to factor, right, now factor x squared minus 9. Is it a binomial? Yes, it is. Is there a subtraction sign separating the two terms? Yes, there is. And are the terms each perfect squares? Are they perfect squares? Is x squared a perfect squared? Yes, it is, because x times x gives me x squared. And is 9 a perfect square? Yes, it is, because 3 by 3 gives me 9. So then I can factor that using x minus 3, x plus 3. Okay, another way to think of this in terms of a trinomial is to think like this. We could also say to ourselves x squared plus 0x minus 9. If I want to factor that, I'm looking for factors of 9 negative that add up to 0. And so if I think about my factors of 9 that add up to 0, that's a negative 3 and a positive 3, right? So then I can say, well, that's x plus 3, x minus 3. And that's another way to think of this. But most students don't stop and go to that extent, so I think it's good to recognize these three steps. Is it a binomial? Is it a subtraction? And are they perfect squares? Okay? Again, let's look at the next one here. Let's expand x plus 9 times x minus 9. If I expand that, we get x squared minus 9x plus 9x minus 81. The two middle terms here, they of course cancel. And we end up in the end here with x squared minus 81. So again, if I gave you x squared minus 81 and said factor that, how would we go backwards? We recognize that this is a minus sign. These are both perfect squares, and our pattern is the square root of x squared minus the square root of 81, which is 9, and the square root of x squared plus the square root of 81, which is 9. And that's how we factor that. Okay? It works even if there's a coefficient in front of our x. So for example, if we expand 2x minus 5 times 2x plus 5, we will get 4x squared plus 10x minus 10x minus 25. These two middle guys cancel, and we end up here with 4x squared minus 25. So then if I gave you, again, 4x squared minus 25 and said factor it, you would go through the checklist and we would say, is it a binomial? Yes, it is. Are the two terms separated by a minus sign? Okay, is it subtracting, right? Is it a difference? Yes, it is. And are these perfect square monomials? Is each term a perfect square? And yes, they are. So I recognize the square root of 4 is 2, and the square root of x squared is x. The square root of 25 is 5, and that's 2x and 5 again. And I usually put the minus sign first. It really doesn't matter. We can use plus or minus, or it could be 2x minus 5 times 2x plus 5. Okay? So if we go back here, and it says factor the following, k squared minus 64. I'm going to go through my checklist. Is it a binomial? Is it a subtraction sign or a difference, right? Is it a difference? I take the difference, just means subtract. And are they perfect squares? So let's go through our 3 questions. Is this a binomial? Yes, it is. Is it a difference? Yes, it is. Is k squared and 64 both perfect squares? Yes, they are. So I'm going to write this like k minus 8, k plus 8. Okay, and if I wanted to do a check, I could expand that, and I would get k squared plus 8k minus 8k minus 64, which would be k squared minus 64. Okay, let's look at question B. Is it a binomial? Yes. Is it a difference? Yes. Is 9m squared and 16 both perfect squares? Yes, they are. So we rewrite that. We're going to factor that like 3m minus 4, 3m plus 4. Okay, let's look at the next one. 3a cubed minus 12ab squared. Now the first thing I recognize right away is I've got an a cubed. That is not a perfect square. But I also know I've got an a over here as well. So prior to doing any kind of factoring, regardless of if it's a binomial, trinomial, etc., we always want to take out the GCF. Now we didn't do that in the first two because there wasn't a GCF. So let's take out the GCF first. We take out our greatest common factor. I know that 3 goes into both 3 and 12, and I've got an a in both of those terms. So if I take a 3a out of 3a cubed, I'm left with a squared, and 12 divided by 3 is 4. I've got a negative 4b squared. So now I'm going to look at my resulting binomial. Is it a binomial? Yes, it is. Is it a difference? Yes, it is. Is a squared and 4b squared both perfect squares? Yes, they are. So I've got a 3a, which I just carry down, and my binomial factors into a minus 2b and a plus 2b. Okay, let's look at the next one. I don't have a GCF there. Is it a binomial? Yes, it is. Is it a difference? No, it is not. So this cannot be factored. It's not a difference of squares. Therefore, it cannot be factored. Okay? And if you try to factor that, if you think to yourself, well, maybe it's just 2a, 2x plus 5, and 2x plus 5. If you try that, then you will get 4x squared plus 10x plus 10x plus 25, which is 4x squared plus 20x plus 25. These two terms do not cancel, so this cannot be factored. Okay? And in fact, the only way you can factor a binomial is with either a greatest common factor or a difference of squares. Okay, let's look at question E. X to the 4 minus 1. Okay, when I factor this, is it a binomial? Yes, it is. Is it a minus sign? Yes, it is. Is x to the 4 a perfect square? Yes, it is. X to the 4 is x squared times x squared, right? X squared squared is x to the power of 4. And so when I factor this, we get x squared minus 1, x squared plus 1. Now, a little trick here. Whenever I see a 4, I'm probably going to have to factor twice, okay? Often factor twice. So when I see this x squared minus 1 here again, this one here, it's a binomial, it's a difference, and x squared and 1 are still perfect squares. So I can factor this one further. X minus 1, x plus 1, x squared plus 1. This guy just gets carried down. Okay, let's hold off on, well, we can do f. Let's do f. So this is a perfect square in sort of disguise. Okay, if I look at the x minus 2 squared minus y minus 6 all squared, I can use substitution. I'm going to say let a equal x minus 2 and let b equal y minus 6. So now I've got a squared minus b squared. So that's, of course, a minus b times a plus b when I factor that. But now I need to sub back in my x minus 2 and my y minus 6. So when I substitute that back in, I get an x minus 2 minus b. And let's just do the outside brackets in black here. Oh, and sorry, my b here. Let's just slow it down here. My a is x minus 2 minus our b, which is y minus 6, and again our a is x minus 2 plus our b, which is y minus 6. So where I see a, I subbed back in x minus 2. And where I see b, I subbed in back in my y minus 6. Now when I simplify each side here, I can take and distribute this negative sign. So on my left hand factor here, we've got an x minus 2 minus y plus 6. And on our right side, we've got x minus 2 plus y minus 6. And when I finally simplify, we get x minus y plus 4, right? X minus y and negative 2 plus 6 is 4, and x plus y minus 8. X plus y, negative 2 minus 6 is negative 8. So here's our final answer here. And this one's definitely an excellence type question. There wouldn't be a ton of those on an exam. Maybe you would see one. Okay? And then if you wanted to try these last two questions, if you want to pause the video and give them a try. Okay, if you wanted to do this one, first thing you could do is right away you could rewrite this as negative m squared plus 81, but that's of course not a difference of squares anymore. There's not a minus sign in between. But we could then factor out the negative 1 as if it's the GCF, and then we would get a negative m minus 9, m plus 9, or we could just simply do 9 minus m, 9 plus m, okay, in that order, and that would be the same thing. And then the next one here, and the last question, if I take out my GCF of 8, we get x squared minus 9. And of course, x squared minus 9 is a perfect square binomial. Difference of squares, perfect. It's a difference of square binomial, which is x minus 3 and x plus 3. Okay, so hopefully that makes a little bit of sense. And good luck on your assignment. If you have any questions, please do not hesitate to contact me. Thank you.